All right, so let's get to our next, and let's do this a little different. All right, there's our table, and now we see our problem. We have something, our x is squared plus a number. This is written backwards, but it's saying our substitution should be tangent. And that angle needs to be dropped between negative pi over 2 and pi over 2. Because we're going to use inverse trigonometry where we're only, well, it's only defined in certain quadrants. That's only defined in quadrant 1 and 4. So, what are we going to choose for x? I think we should choose x to be something with a tangent. Should we choose 4 or should we choose 2? Right, because it's a squared. That 4 is 2 squared. So we're going to say x is equal to 2 tangents of theta. And we can say that dx is equal to 2 secant squareds of theta d theta. Now, I don't even want to start the problem yet. I want to start my triangle. You're going to need a triangle at some point in time. So since we're in between negative pi over 2 and pi over 2, doesn't matter, just make your triangle in the first quadrant. And let's see what we can do with this. So let's divide over the 2, and we're going to end up with x over 2 is equal to tangent of theta. Just want to create the triangle. So we get x on the opposite, 2 for the adjacent, and the hypotenuse is going to become, I'm just jumping to it. That is not a coincidence. That is not a coincidence. And there's our angle. We'll be back for it. You're going to have to do that unless you can just, there's the answer. I doubt that. I doubt you're just thinking of it. So now let's go through and do all of our subs. So it says we got an x squared. So we pop in our 2 tangents. And then we have the square root of something squared plus 4. And you'll be able to skip a lot of these steps. Like, just full disclosure, this is painful for me to write it out and to do all of these steps. Because there's a result we know that's going to happen. Okay. Let's start to clean. I'm not even going to pull any numbers out. I'm just going to put the 2 secant squareds of theta up top. Down below, we're going to square this. This is going to become 4 times tangent squared of theta. And then inside of here, we're going to get 4 tangent squareds of theta plus 4. Of course, it's all d theta. Can you see that the square root of 4 is going to pop out of this bad boy? Maybe not. It's okay if you can't. Maybe you're not seeing it. Oh, that's a 2. So we have our secant squared of theta over 2 tangent squareds of theta. Let's factor out the square root of 4. That's 2. Did you catch that? I hope so. Now let's just start cleaning. Take the 2's out. They go into the denominator. So we have a 1/4. Our secant squared of theta still hangs out on top. We have a tangent squared of theta. And now we have the square root of tangent squared of theta plus 1 is secant squared. And since we're in quadrant 1 and 4, we can take the square root of secant squared and it's just going to be positive secant. So at this point in time, I'm canceling this and this because that's just secant when that theta is in between pi over 2 or negative pi over 2 and pi over 2, which is positive. So we can just cancel that out. Now let's keep rolling. We're almost there. We're almost done. The integral of secant of theta over tangent squared of theta d theta. Now at this point in time, I'm guessing sines and cosines is going to be the best way of going about this. I don't want to deal with all this freaking nonsense like that. So 1/4. This is 1 over cosine of theta. And then we're going to multiply by its reciprocal. Did you catch that? Tangent squared, sine squared over cosine squared. We just flip it up and we multiply. So the cosine cancels and the square cancels. So we are left with 1/4 the integral of cosine of theta over sine squared of theta d theta. Now at this point in time, I'm certain you see the u sub. I'm certain you see the u sub. U is equal to sine of theta. Du is equal to cosine of theta d theta. So we have ended up with 1/4 times the integral of 1/u squared du, or 1/4 the integral of u to the negative second du, because that's a little simpler for us to work with. Now let's take the antiderivative. So we're going to add 1 to our exponent, and then we're going to divide by that number. Let's call it negative, plus c. So we have negative 1/4 over u with a u in the denominator. So we have, what is that? Negative 1/4, 1 over sine, plus c. Oh, it's negative 1/4 cosecant of theta plus c. Holy moly. Phew, we're done. No, we started in terms of x's. So let's take this up to the top and see if we can't solve for cosecant. Look at all that work. Look at everything we just passed up. Oh my goodness. Now what's cosecant of this equation? Cosecant, I believe, to be the height over the opposite. So that's going to be the square root of x squared plus 4 all over x. So my friends, here is our answer. Let's go. Let's go. And there's our solution. Now, these can be extremely challenging for students, especially if you don't know your trigonometry. There's so many spots where you actually have to, you got to know your identities. You need to know how to make a triangle. You got to know which freaking quadrants you're in. Your algebra better be on point. You better know how to do u-subs. Dude. This is the section where all of a sudden we go from, well, I can maybe do this, to all of the holes in your game are going to be exposed dramatically if we don't know our trig. Please learn your trig. Let's make sure that we're good with this stuff. Shoot. I would stop. I'd go look up trig stuff before even keeping going, or you just want to keep going and building your foundation on sand. We all know that parable. Not knowing your trigonometry is building your foundation on sand. It will continually crumble. No matter how good of a frickin' you are with wood and building a house, it's going to keep falling down because your foundation sucks. We must be strong with trigonometry or we will not be successful in this class. So, I think you're seeing it now, huh? All right, I'll stop babbling. See you in the next.